Bismillahirrahmanirrahim. My name is Muhammad Ilyasa bin Hazami. I am from class CEE532 Today I will present for my group mini project, which is for task 1 linked list. Briefly explain for the linked list. A linked list is a linear data structure in which elements are not stored at contiguous memory location. The elements in a linked list are linked using pointers. And in simple words, a linked list consists of nodes where each node contains a data field and a reference to the next node in the list. Figure in the left is a linked list example. To construct a linked list with 5 elements, for my group mini project, we will enter 5 elements. So, step first, we need to declare head and tails and set it to none. Step second, we need to create the first node and insert to the list. Head equals to node, tail equals to head. As the figure shows, it will happen like that. Next, adding the second node. To add the second node, we need to create the second node and insert it to the list. And we need to point the tail.next to the node. Then we need to point the tail to the tail.next, which is the new node. This is for the third node. Same as the second node, create the new node and insert it to the list. Point the tail.next to the new node, and then point the tail to the tail.next, which is the new node. So, to implementing the add or insert, there are 3 methods to done it. The first method is add first, the second method is add last, and the third method is add at the middle. So, on our main project, we have implemented the 3 adding method. At line 129, it will define the function to sign up the new customer. And to sign up the new customer details, we will use the 3 method in linked list. So, the next line 130, we will display the print menu, and the print menu is option 1 to add first, option 2 to add last, option 3 to add insert, and option 4 to return to the main menu. Next, the user will enter. So, if the user enter option 1, which is if user want to using the add first, variable A, B, C, D, and E will store the data of the customer that user have entered. A for ID, B for names, C for contact, D for month for rent, and E for the storage unit. So, when the user enter the customer's detail, if the storage value that user entered are greater than 50, hence it will print exceed storage unit. The storage unit does not exist. The facilities only have 50 storage unit. So with the 50 storage unit and 5 data insert for the customer details, we will get 250 data insertion in this linked list. So when all the details have been inserted, the lst.add first will perform the add first method. So how the add first function perform? This is the code for the add first function, which is at line 22. Firstly, we will create the new node and insert the 5 details data on the new node. So this is the figure to show what happened for the line at 23. Next, the line for 24, new node.next will be self.head. So new node.next will add self.head. Next, self.head equals to new node, and then head will be at the new node. Self.size will increase. So previously we have the size of 2 in linked list. Now we have the size 3 in linked list. So this is the result. The new node is ID 3 will be at the first, because we implementing the add first. Next, if the user choose option 2, which is to implement the add last, as mentioned before, the user will enter the details, 5 details: ID, name, contact, month rent, and storage unit. And then if storage unit are not exceed, and then if the storage unit are not occupied, we will enter the customer's detail for the new storage unit. If it's occupied, we will say to the user the storage is occupied, so need to enter the other storage that are not occupied, and it will display the occupied storage. To implement the add last at code line 154, we will see at code line 32, this is the function of the add last. So implementing the add last, we will need to create new node and then insert the data customer details into the node. This is the figure. Next, if detail are none, so this is if there is no element in the linked list, but here there is 2 elements in the linked list, so we will go to else. Else self.tail next equals to new node. So at the tail, it next will go to the new node, and then self.tail equals to self.tail.next, and then the tail we pointed to the new node. Self size will be increment. Before have to list in the linked list, have to list in the linked list. Next have 3 list in the linked list. So this is the result of the add last. So if the user enter the third option, which is to insert at the middle of the linked list, third option, the linked list to insert will be run at line code 171. This is the call function for the insert. So after the user enter the details and the index to enter, which is the specified place at the middle to enter the customer's details, and then we will go to the linked list definition function for the insert at line 49. So to implement the insert at middle or at index specified, if index equal to 0, so it will insert at the first, as same as the at first method. If index greater than self size, this self size is 2. If index is greater than self size, which is 3, then it will perform the add last. Next, the else is to insert in the middle. So to implement the insert to the middle, current equals to self.head. At head there is current, and then it will go to the for loop to see the index, to go to the next index selected to add the new customer detail. For example, here there is 2 size, so the user will enter the index is 1. So head is the 0, index 0, tail is the index 1. So the range is I in range 1, so I is at 1. Range for index is 1, so 1 and 1 the loop will not be entered because it has achieved the range. Then the temp will be equal to next.current. The head is current, and then the temp will be equal to current.next. The head is current, so the current.next is at the tail. So we will add temp at the current.next. And then at line 59, current.next equals to node AB, new node. So current.next will add to the new node. Line 60, current.next.next. So this is current.next, and the current.next is the new node will be at the temp. This is the figure shown for the line 60, and then the self size will be increased. So this is the result. The new node ID3 will be at the middle. Next we will move to the remove or deletion. There is 3 methods to remove, as same as the add. First method is remove first, second method is remove last, and the third method is remove at the middle. In this program, the remove will be at option 2 if the user enter to delete the data from the list. So they will go to the option 2. At the option 2, we will display to ask the user to enter the number ID that want to be deleted. If user enter the ID, and then the ID will be stored at A, and then I has been declared to check if the ID exists in the linked list. If the check ID return no, so I equals to no, there is no customer ID in the linked list. So the program will not delete any ID or details of the customer in the linked list. If check the ID and the ID is exists and it exists at the index 0, then it will perform remove first. So 196 we will call function remove first. So the remove first, line 65, this is the function definition for remove first. So if the size is 0, there is nothing to be deleted. Else, so to implement the remove first, this is the diagram. For example, there are 3 size of list. So first, temp equals to self.head. So we will add temp at the self.head, at the head. Next, head equals to self.head.next. So head will go to the next. So this is the current head. And then the self size will decrease by 1. So before have 3, now have 2. So this is the current linked list. So there is no ID1. There is only ID2 and ID3 because ID1 have been removed. ID1 is at the index 0. Next, if the user enter the ID and the ID is at the, if the ID have been checked and it exists and it is at the last size, the index at the last size, and then it will perform remove last. At line 202, we will call the function remove last. So the function definition for the remove last is at line 78. If the size is 0, there is nothing to remove. If the size equals to 1, there is only one list. So for the example here, there is 3 size, the size is 3, then it will go else. Current equals to self.head. So at head, this is current, and then it will be loop. It will make the loop until at the second last. The size is 3 minus by 2, so at index 1, at range 1. So this is 0 and this is 1. So this is the second last. Then current will be at the current.next. It will stop right here because it has achieved the I. Then temp equals to self.tail. We will add temp at tail, and then the tail will be self.tail equals to current. Then tail we add the current. Next, self.tail.next equals to none. So this is the tail. Previously it has the value and linked the next to the temp, but now it has been removed the linked, so it will be none. So next, size will be decreased by 1, and this is the last result, ID1 and ID2. The ID3 has been removed because it is the remove last. We will proceed to the remove at middle. So if user enter the ID and the ID will be checked, the existing ID is at the middle. For example, here at the index 1. So at line 212, remove at will be called, and then will be given the index of the ID that have been held. So at remove at, this is the definition for remove at line codes 100. So if the index is less than 0 or greater than the self size, greater than 3, for example here, it will return none because out of range. If the index is 0, it will implement the remove first. If index is at the self size minus 1, which is index 2, and then it will implement the remove last. Else it will implement the remove at. To implement the remove at, previous is equals to self.head. So at head there is previous. Next, for the loop I index is 1. For example here index is 1 at the middle. So the loop will not get into the loop because I has been achieved equals to 1 at the range 1. So next is current equals to previous.next. So previous, this is previous.next equals to ID2. It will be current. Previous.next equals to current.next. Then previous.next, here is the next. It will be linked to the current.next like this. Next, the middle will be deleted because it is not being linked from the head to tail. So the self size decreased by 1, and this is the last result. ID2 in the middle have been deleted by implementing the remove at the middle. Lastly, for the linked list, task 1 is to implement the sorting algorithm. The sorting algorithm that I choose is the insertion sort. So for the insertion sort in the program at line 188, this will call the function for the insertion sort. So the insertion sort will be at the linked list module at line 385. So for the insertion sort, this insertion sort is to sort the based on the ID, and the ID will be sorted in ascending order. So here is the example of the ID. Firstly, at line 387, we will make the loop to traverse all the ID starting from index 1, and then we will compare to index 0. So starting from index 1, I equals to index 1, starting at index 1 in for loop. Next, key equals to self.get I. Self.get I is to get the element of the ID at index I. Index I now is index 1. So key will be the ID at index 1. Next, key 2, key 3, key 4, key 5 and key 6 equals to self.get2. Self.get2 will return the element for ID, name, contact, month, rent and storage individually. Key 2 will hold the ID, key 3 will hold the name, key 4 will hold the contact, key 5 will hold the month rent and key 6 will hold the storage unit. Next, we will move the element that are greater than key to one position ahead of their current. Next, j equals to I minus 1. So j equals to index 1 minus 1 is index 0. So here is j. While j is greater or equal to 0 and key is less than or less than self-get j. Self-get j is the ID at j. So is j greater or equal to 0? True. And is ID 2020 less than 2021? True. So it will enter the while loop. So the temp will be held the details at index 0 and then the self set is to replace j plus 1. Replace j plus 1 is at index 1 with temp, temp2, temp3, temp4 and temp5. So it replaced. Previously is ID 2 and ID is 2020. Now it is ID 1 and ID is 2021. The self set is to replace. So how the self set perform? The function set perform by remove the element at the index and then add the new element at the same index. For example, at the first index, first 0, it will remove first and then it will add. Same goes to the last. It will remove at the last and then we will add at the last. So it is as the analogy for the sub for football player. 11 player on the court, 1 player sub with the player on the bench. So the size of the player on the court is remain the same, but the element, the player will be different. After self set, after we replace the index I with index 0 details and then j equals to minus 1, so j now is negative 1 and then the loop is j greater than 0 or 0? False. So because of this is a boolean and so 1 false, so it will not enter the while loop. Then we will perform self set j plus 1. J plus 1, negative 1 plus 1 is equal to 0. At index 0 will be replaced for the variable have been held at the key. So key is 2020. All details for the ID 1 for the student ID 2020 will be at index 0. So that is why ID 2 is at index 0, ID 1 is at index 1, and the ID as we can see here 2020, 2001 is sorting by ascending order. Next, the for loop will be increased. The next for loop is index 2. For the index 2, the key equals to self get index 2, so key will be held the index 2 ID. Next, key 2, key 3, key 4, key 5, key 6 will hold all the details, name, contact, month and storage unit for the index 2 at the linked list. Next, j equals to index 2, 2 minus 1 equals to 1. So now we will compare. Is j greater than 0 or is 0? So true. So next is key. Key is 2021, 49. Is less than self.getJ. So element ID at j is 2021, 39. J is 2021, 39. So it is false. So because of the boolean and when it's false, we will not go to the while loop. So proceed. J equals self.set j plus I. So j plus I the value will be remain at here. There is no need to sort. So next loop, for the loop index 3, key is to 2021-78, and then the while loop, is it true j equals to 0 or greater than 0? True. Is it true that 2021-78 is less than 2021-49? False. So will not be replaced. Next, for the 2019, is it true that 2019 is less than 2021? True. So it will be replaced. Next, the while loop will continue replacing the index 4 with the previous details at the previous index. For example here, ID 5, so it will be replaced. There is ID 2, ID 4, and then replace again, looping until the 2019 has placed at the right index. So 2019 place is at index 0, so now this is the 2019 place. As we can see here, it is true that the ID has been sorted with ascending order, starting 2019 as the smallest value of the ID among the others, and then the 2019 ID is for the customer number 5, but because of its ID is the smallest among the others, so it will be sorted so that his place is at index 0. That's all from me. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz Kitan Shamris and I am from Group 4. So today I will present about mini project of ECE532. So I did the task 2, which is for the 3. So in option 1, so this is in option 1. So for the option 1, there is a 3 insert where there is a A, B, C, D, E. A is for ID, number ID, and then B is for customer name, C is for contact number, and D is for month to rent, and E is for storage unit to rent. So what will happen here is it will display performing insert 3 where it's showing all the data entered by the user into the system accordingly. So it will perform the insert of the data where all the user key in all the input. For example, for ID, they will insert the ID in A, and then B, they will put the name, and then C is the contact number. So all of this data will be insert in 3, and then it will followed by 3 dot in order, where it will show and display all the display the traversal of existed data that has been entered by the user, which is the data that I said just now, and it followed by 3 pre-order and then 3 post-order. It's all the same, just the sequence of the data will be different. Then next is option 2. So for option 2, it will display number ID want to delete, and then after the ID number has been entered by the user, it will check first whether there is ID exists in the list or not, which is this list.check ID, and then if the ID is exists in the list, this 3.delete will perform the delete 3, and it will be repeated for the remove first and the remove last. And then after all the delete operation finish, there will be the 3 in order, 3 pre-order, and 3 post-order, where again it is to display the traversal of the data that left in the list, and it will be different after the delete has been performed, after the performing of the delete. So next is for the option 3. in this option 3, it is to searching algorithm in the system. First, we define X as a tree.search, where and A is to input to put the customer ID where we want to search the customer ID. So A will be the input, and then X is defined as the tree.search, and then the tree.search will find whether the A is existed in the tree or not. If the ID number entered is valid, the system will say yes, and it will show the path of route to the wanted customer number as path has been defined as tree.path. And same again, after that it will show there is a tree.inOrder, tree.preorder, and tree.postorder, where it will show the traversal of the data. And here the tree get size is to find the value of the tree that left in the data in the program. So next, for 3, it evolved in the option 5, which is the last option. So here there is a write list and write tree. So for the write list and the write tree, this is the file that we will use. Write is to write data and save into a file, into a JSON file. And then for the read will it will read from the file JSON, and then it will put it back into this program. Here we have save and read data linked list in the file using JSON. So here we have write tree, where for the tree, and this definition write.tree, where it will write all the data in tree and then save it into file JSON. So next we have here read tree, where this definition read tree, it will read all the data from the tree that has been saved in file JSON, and then it will put it back in the program. So it will we have like 5 read tree here: read 3, read 2, read 3, and read 4, and read 5. For read 3, it is for a mini project ID tree.json, and then next is read 2 is for mini project name tree.json, and then read 3 mini project contact tree.json, and read 4 read 4 mini project month 3.json, and then the last one read 5 is mini project unit 3.json. So here we can see that the tree has been declared as a binary tree, and then this line right here is the definition that is involved with all those files. So this is very important. So this is the definition. So this is a definition function insert existing linked list, list and tree. So here we have a read list until read list 5, and then read 3 until read 5. So what happened here is, for example, for F read 3, it will read the data in mini project ID 3, because up here I already state that read 3 is for mini project ID 3. So it will read that data from mini project ID 3 listen, and then save it in F, because here it declares F, and then it is the same with G, H, J, K. And then down here we have a loop where it has a range length A, where length A is to see how big is the array in this system, in this program. And then tree.insert right here is it will make a loop in the system to save data in tree. So I think that's it for me for task 2, 3. So next I will explain about the system.
Hello, good morning to Dr. Rosina. My name is Muhammad Rami Muhammad Kamel, and today I'm going to present the program for task 3, which is constructing a graph. In this task, there are two tasks that we should do, which is searching algorithm in BFS and DFS order, and then perform the minimum path method using any method, using all of this method. So let's look at the program. Firstly, this is the program that we will use, and first of all, this is the menu, and my task is for graph. This is option number 4. So let's jump to option number 4. Okay, so this is the program that used to execute task 3. So when firstly, the program will ask user to choose which option they want, and if they choose option number 4, it will print all of the number of vertices and edges for the graph that from this graph.get size. This can be get from this one, the edges and the vertices that used to create the graph. Then we move next. After this, we move to graph print weightage and print menu number 3. Okay, menu number 3 is display program selection. So user should choose what their option. So menu number 3, there are 4 option, which is contain BFS, DFS, shortest path, minimum spanning tree, and main menu. So after they choose this one, so let's say they choose for the option number 1. If they choose for option number 1, the program will ask user to enter the location that that they want in the DFS order. DFS order. So then for if j in vertices, this is used to check the root availability from get index. Get index is a return value from this library. Get index, return the index for the specified vertex. If there is a root, it will perform the next line. If not, it will be a wrong input, does not exist, and return to option number 4 again. So if the user insert the correct input, then it will be perform the BFS get search order, which is it perform the BFS order, and then print all of the parameters that need required, and get number of vertices found is the return value from this. So this is the return number of vertices found. It will return the self search order to this one, search order, then print. So for I in range of search order, which is in range of this value, a certain value, it will make a loop and print out the graph vertex search order that can be get from this one. return the vertex at the specified index from self-vertices index. So it will show all of the vertices that contained in the graph in the BFS order. So basically this line will perform the BFS and show the result. And then to make it more clear, this line was used to show that which parent for every vertices. So for I in range access order, which is the value from just now, you get this, we will making a loop and print out the parent for each vertex. From if get parent, this return value will be get from this one, the return value return the parent of the vertex. So each vertex the program will show which of is their parent, and then print all of the result. So this is if loop. So this one S is we used to when user enter the wrong input, which is this one. Example Sungai Petani, if they type in a wrong answer or wrong input, then the if loop will return to option graph, to the menu again. So let's move to the DFS order. So the second option is DFS order. It is the same process from DFS, but this one is DFS. Firstly, it will ask user to enter the root availability, to check the root availability for I in J in vertices graph get index. This will get the return value from get index. Cell vertices return the index for the specified vertex. If the root is available, then it will execute the next line, which is performing the DFS. So all of these parameters is same like the BFS, but the order is different. So get sys order, they also the return value from this one, this library, and then it will print out the answer, the result according to the route that has as user choose. And then for I in range, it will print out sys order in range of sys order, which is this. To make a loop, and then it will print out all of the return value from get vertex sys orders I, which is from this one. And then the same thing, the same process happen, which is it will show the parent node for each vertex, and all of these parameters also are the return value from this library, which is get vertex, this one, get vertex. Then if user wrong enter the wrong input, then it will break from this loop and return to the option number 4, which is the selection menu interface. Then we move to option number 3. Option number 3 is minimum path method, which is will perform the prims, Dijkstra, and Kruskal. So at this one, first thing, the program will ask user to enter the route, which vertex is the route, and then if j in vertices, it will check the route availability and graph shortest path. This line will perform the shortest path, return the value returned from this library. This one, shortest path, get shortest path, and this one, find single source the shortest path, and it will return the value to this line, and then this also is the return value from the library just now, which is this one, search order. In order to get the minimum path, we use multiple route to compare which path is the minimum, which path contain the minimum cost. So during this process, the weightage became one of the reason and one of the option, the comparison we use to choose which is the path that the graph will use. So and we can see the next line, it will ask the user the destination that they want to go, so that the program can show user the shortest path from the route to the desired destination, and then print the shortest path. Get this one is also the return value from graph, which is this one, get path from this one, this path, and get index also, and then this is the main important thing, the cost, the weightage of the graph. It will choose the most minimum value from the library of weighted graph, which is this one, get cost. This definition function definition will return the cost from path from the route to the desired vertex. And basically this line will show the user the path from where they want to go to the destination, which vertex it will choose, and the total minimum cost. And then we move to option number 4, which is the minimum spanning tree. So minimum spanning tree, basically we will use the Kruskal and prims method. So firstly, it is the same thing, that the program will ask user to choose route, and if j in vertices, we check the route availability, and then to perform the MST, binary tree also involved in this program. So get minimum spanning tree perform MST from return value from weighted graph. Which is this one. It will return self.get minimum spanning tree to get a minimum spanning tree rooted at vertex, and then print out the total weight used in the minimum spanning tree. So basically this is the line that we use to perform the MST. The total weight, this is the root chosen, and then show the answer. So for option number 5 is option number 5 is to return to the main menu. And else, since we using the if loop, so if user enter other than this 5 option, it will return back, break the loop to option number 4. Okay, so that's all the code that I use to perform task 3. Thank you.